This video is going to describe what is considered to be or was considered to be a myth for pilots in the fact that it was dangerous to turn when you're flying in a headwind. And experienced and knowledgeable pilots, other experienced and knowledgeable pilots would say that no, this is not a problem because the wind does not matter when you're flying, other than for navigational corrections, because you're flying in the air, which if the wind is not gusty, then you have a constant flow, and you just treat that as you would the sea for a boat. That you're not the flying characteristics are not affected by the fact that the wind is moving, because you're moving relative to the wind yourself. Well, I looked into this and found that there's a lot more to it than that, and so I call this the headwind mystery. But it applies not only to headwinds but to crosswinds too. So let me describe how the study of inertial frames of reference helps to explain this phenomenon, and perhaps it will satisfy both sides of the argument, because usually when people disagree, they're both right and yet they're both wrong. Both right because it depends on the circumstances as to whether one is true or the other, and they're both wrong because they don't allow for the other person to be right. So I'm going to try and settle that problem. So let's just have a look and see if we can apply some science to this. The problem does not arise when you're flying at altitude, because high altitude, because there the only reference really is the wind or the air, and you're flying in that, and the ground, the movement of the ground is not very rapid, and you do not need to turn suddenly if you're just changing direction to correct for a navigation error or for a change in the wind strength or direction. But it does occur at low altitude when you're in what's called an airport pattern. If you have a runway like this, perhaps runway 19 perhaps, you're going to land there. If you're a general aircraft, that is to say one of the smaller aircrafts that's not on a regular schedule, then you're not directed landing at an uncontrolled airport, that is to say one without a control tower. You instead of being told how to approach the airport, you follow a pattern. And a typical pattern, such as the one that I was using when learning to fly in Mansfield, Massachusetts, is that assuming that you try to land in the wind, into the wind, and take off into the wind wherever possible, because this means that you're traveling lower speed over the ground in order to get the airspeed to fly. You take off at about 70 miles an hour or 70 knots in a small aircraft. But if you're approaching to land, you often come in on this leg here to fly over the runway to check the windsock, to look for the wind direction, to make sure where other aircraft are that are preparing to land or that are taking off, so you get to know where you can fit into the pattern. So then when you've gone that far, you make a turn, and usually these patterns are left hand or anti-clockwise, but some airfields are not, depends on the geography. So you fly here across like that, and then you fly relative to the ground, you fly downwind, and then, assuming that there's nobody coming straight in, as some aircraft do, particularly larger aircraft, for example a jet or a twin engine aircraft might well come straight in, If it's free to land, you turn here and come in and touch down as early as you can and leave the runway by one of the exits. Now that's ignoring the wind. But if you have a wind, you must allow for it. And so if there's a strong wind, let's say that you're flying in at 70 knots. These are your air speeds. Flying at 70 knots, and let's say there's a 20 knot headwind. Now that's more than you'd not expect to find. Not too many people would want to fly a small aircraft in a 20-mile-an-hour wind. But it means your ground speed, since you're traveling at 70, we'll say miles per hour, through the air. If the air is going that way at 20 miles an hour, then you're traveling over the ground at 50 miles an hour. 50 miles an hour over the ground. When you turn here, you're going to be flying across the wind, and you adopt a heading that is partly into the wind so that you don't get driven that way. You come down here, and because you're now flying at 70 miles an hour through air, you're traveling this way at 70 miles an hour because that's the way you're facing, and the wind blowing that way keeps you that position over the ground. But you're flying through the air at 70, but you're going over the ground, let's say 60 for rough figures. 70 still through the air, but about 60 over the ground. Then you come down to here and you turn again, and now you're going downwind at 70 miles an hour through the air, but the wind is behind you at 20 miles an hour. So over the ground you're now traveling at 90 miles an hour. And then you get to here. At this point you reduce your engine speed because you want to start slowing down. You want to go over the end of the runway at about 40-45 miles an hour in a small plane. And so you begin to descend. You're about 1,000 feet at this point. And you want to descend down to about 500 feet at this point. And you want to slow down so that you're traveling here at about, say 50 miles an hour. And you're slowing down here. And so by the time you get to 50, now you've got to turn. And you've got to face into the wind a little because the wind is blowing you that way. So now you kind of face that direction, and you're doing about 50 miles an hour, which means you're doing about 40 miles an hour roughly over the ground. Then you get to here and you slow down to about 40 miles an hour, and which is about 20 miles an hour over the ground. So you see how the wind, the 20 mile an hour wind, affects your ground speed, but you keep your airspeed what is best for flying. And when you land, you'll slow down to about 35, and so you're ready to stall, and you try to stall as you touch the ground so that you lose all your lift, and then the plane stall means that the air is going so slowly over the wings that they don't produce enough downdraft to keep you up. There's also what's called a ground effect, where you begin to compress the air against the ground, and that helps you to cushion a little. And you know when to level off and slow down and stall the aircraft just as you land, so that you lose your lift and then you don't try to take off, even though you've got a wind ahead of you. So by the time you come to a stop, the wind is still at 20 miles. So you want to be going really slow when you land, and then you put your brakes on and then leave the runway. Now, the problem with this, of course, is, you may have noticed, that here you don't make much of a turn. You don't make a full 90-degree turn. I think, and so this is no problem. We have to slow down relative to the ground. We're doing, speed up relative to the ground, because we're doing 50 there and 60 here relative to the ground, but we stay at the same speed in the air. That is not a problem. You do usually apply a little extra engine power as you turn anyway, because of the fact that turning reduces your lift and you tend to lose altitude, so you put a little extra power on. And you need to here too, because even though because you need to actually apply a little extra energy. Now, this raises a very interesting point that I'd never met until I began to study this, and that is the energy involved in this rather than just the speed. You see, flying through the air, you need a certain speed relative to the air to get the air to be forced downwards by the way that the wings provide lift due to their shape and their angle of incidence and your speed through the air. But there's also the question of energy. And energy, your speed relative to the air is involved with the lift that you get from the wings. But in terms of your movement and your kinetic energy, that's relative to the ground. It's a very interesting problem, and I've had to study energy a lot in relation to the gravity study. And kinetic energy is a very interesting thing. The kinetic energy of an airplane, even though it's in the air, even if it's very high in the air, is relative to the ground. In the same way, even the moon has its kinetic energy relative to the Earth. And the plane too. So the plane has to speed up relative to the ground, and that requires extra energy. And that means that the wind, unless the wind as you turn will can give you some energy, but you'll lose height because of that. So you have to put a little extra power. But I'm not going to say any more about energy because it's too complicated. But it's something to note. When you get to here, you're facing this direction here, and you now have to face that direction. So your turn is actually greater than 90 degrees. And this is where you get a problem. Well, I'm going to draw your pattern over the ground in a moment, so you'll see that you actually have to make a turn that's greater than 90 degrees here. Here too, you have to, again, you're traveling in this direction, or you're facing in that direction and traveling in that direction. Here you want to travel in that direction, but you must face into the wind to compensate for the wind blowing you backwards here. So here you've got to do more than 90 degrees turn. So both of these spots, and they constitute a risk that if you turn too sharply, you can lose altitude, and particularly with the fact that you're having to increase your velocity relative to the ground here, at this point here, and at this point here, you have to increase your velocity. So that there's a risk at this point here that you could lose height, and if you stall at a low altitude, under 1,000 feet, there is a risk that you may not be able to recover. So here you have to make a sharp turn, and here a gentle turn. And now I'm going to draw with a different pen. I'm going to draw I'll do it with the red ink. Here I'm now going to draw the path that you have to fly relative to the air. Now remember, the air is going in that direction. When you fly here, you're obviously flying in the same direction as you're traveling because you're facing right into the wind. But here, you have to fly in this direction here, relative to the wind. You see, that's the direction you're heading. And although you're flying here away from the airfield in the air is going that way. So over the ground you come down here, but in the air you're traveling in this direction. Then you do your turn, which is more than 90 degrees. Then you fly down here, and you're flying like this. Here, you have to do a turn and fly this way, and although I'm showing you here the wind has blown you to here, so that's where you are over the ground. And here you have to land, and you land somewhere up here in the air, which blows you back to there. So this red line shows you your path through the air, is like that. In the frame of reference of the air. And so these are the turns that are dangerous because they're more than 90 degrees. And my recommendation actually is that if you're in a strong wind in any direction, it's best to, instead, I'll do a wavy line of what I think is the safest way to fly, is to fly more like this, making a large circle, so that you don't have any sharp bends. Same here, fly more like this, in a circle. Don't try to make it a sharp rectangle. Make it very more like an oval. Although it's shorter here, you still take a nice big sweep round, and I'm sure that you'd be forgiven for not following the pattern exactly. So the problem arises when you're trying to fly to a certain shape over the ground when the air is moving. Then you can't just say that you're only concerned with the air. You're concerned also with the ground. I hope this has been of some help in explaining this particular phenomenon and make flying a little safer for you.